About managing state with PartyServer. So when you have a lot of different users all connecting and modifying the same state, it's very easy for there to be a lot of chaos. So you need a system to manage the state. And I think a good solution is state machines. So a state machine isn't anything that complicated. It really is just like, think of it like a flow chart, where there's different rules about when things can change or when things can happen. And imagine like a game, for example, like this tic-tac-toe game. So it's multiplayer because we have 2 players and we have shared state, right? We have maybe an array of 9 cells and we have rules. We can only play certain at certain times. I can only play when it's my turn. I can't put an X over here because there's already an O. So we have and we have different states like, maybe the game's over, right? Right now there's a line through it. So the game is not actually, you can't be played at all. So how would we model that? Well, we can have a bunch of states, playing state, tied state, one state, and we can model that with TypeScript. So imagine that we have a union type here where we can only be in one of these 3 states. Now this is pretty good, but we can do better because normally there's state attached to each, there's data attached to each of these states. So for example, in the playing state, we have the data of whose turn is it. But maybe in the one state, we have the data of where the actual win was. Maybe it's on row 1 or something like that. So certain data only applies to certain states. So that gives us something like this would be a lot better, where we can say, that our playing state is not just the type of state it's in, but also it has extra data like, whose turn is it? It's X or O's turn. Or when we win, we might want to know where the location of the win was. So it's better to define a union type that has all the data associated with that state. And in a state machine, we like to think of events. So imagine that an event in our tic-tac-toe game, an event might be to play a specific cell, a specific XY coordinate, or we might have an event to reset the board. So those are events. Now related to events, we have transitions. Now they're not the exact same thing because an event can happen that doesn't result in a transition. Imagine that you try to play when it's not your turn. Well, then we're not going to transition, right? The event play happened, but we're not going to have the transition to the next turn. So in this kind of tic-tac-toe game, we might have a next turn transition, and we'll probably also have a way to finish the game. So a way to transition to tied or won. So those are transitions. Now here's a code example of what that playing might look like. Imagine that we have a play event and we pass into the play event some parameters. A parameter is the player that wants to make the move, and the cell, where do they want to play? And then we can update the array to say, okay, now it's this player owns that space in the array. And we could also figure out, okay, whose turn is it going to be next? And then we might want to check, is the game over? Is it tied or is it won? Because then we should update the status of the game. So another useful thing when it comes to state machines are guards. And these are kind of like, you could think of them as validation to check whether something is allowed to happen. For example, like it must be your turn, right? You can't play if it's not your turn. We have to check that the square is not already taken. Or we have to check that, that you're allowed to play now, that the game's not over, right? These are all examples of guards. And it might look something like this. So imagine our function I just showed you before. Imagine that at the top of the function, we put a bunch of if conditions and we can check, is the status of the game playing? Otherwise, return. Is it this player's turn? Otherwise, return. Is the cell already taken? Otherwise, return. But notice these are all silent. It's just returning. There's no effect. We could, if we wanted to, we can make them louder. So we can actually throw an error, or maybe we could log it, or maybe even there's an effect like, imagine there was points and you lose points if you try to play when it's not your turn. Well, then, maybe here there would be some function call to like decrease their points, right? So it's up to you how you want to implement your validation logic. Now I'll leave you with a couple tips specifically to PartyServer and Svelte. The first thing I would say on the server side, it's a good idea to create a class for the state machine, like to extract all that logic out of the server, because if you leave it in the server, it's just going to get very messy. So I would put it in its own class. And in that class, what I would do is I would have a way. So imagine this is the game state machine. I would have a way for it to send an event when it changes. This will allow us to broadcast updates to all the parties. So it's a good idea to use this pattern, like an event listener pattern. Now, another useful thing is in our game state machine, because we're in PartyServer, we want to be able to hibernate. So if nobody's playing, right? If the tic-tac-toe game, nobody goes, like our state machine should go out of memory, right? Because we don't want to pay for the hosting if nobody's playing. So we'll need to work with Cloudflare storage. So we'll have to write the state. So when somebody plays, we'll have to update the state in the storage. And then when we initialize the game, we have to check, is there existing state, and read the state from the storage. So this way, we'll be able to hibernate our PartyServer. Now, another useful tip is to have shared types. So imagine our tic-tac-toe game on the server and the client, we probably are going to use very similar types. So it's a good idea to have a shared types folder. Now, inside Svelte, I find it also very useful to extract a class, similar to what we did on the server, but this is specifically to Svelte, to have a reactive state class, and it abstracts over the party socket. And this way we keep our Svelte UI super clean. We're not, putting a ton of logic about all the logic about talking to the party socket. Better to abstract that into its own thing. All right, guys. I hope you like this. Comment below if you have any questions. I'm a new channel, so please like and share. And I'll also drop a link to the code if you want to take a look at the code for the tic-tac-toe game. All right. See ya. Cheers.